Okay, so this is the start of lesson 2.1.3, which you will also hear in this little video that I have off to the right that you can see on the screen. It's going to talk about the equation y equals a times x minus h squared minus k. That's the vertex form of a quadratic equation. There's many forms. You're used to ax squared plus bx plus c. This one is just a little bit different, easier to graph from. They also like to call it the graphing form. So it's going to talk about identifying which parameters a, h, and k affect the orientation, whether it's vertical shift also or horizontal shift, vertical stretch or vertical compression of the graph, and then how it relates to the y equals x squared. You'll see in the video the parent function staying put while you can play with the parameters and change them to see what happens. You're going to see what happens, what a vertical stretch is, what a vertical compression is. You're going to see, what happens and how the graph, what happens to the parameters to make it flip vertically, and what causes things to shift left and right. You're going to hear the discussion of all of those. So let me just get into the video right now and let you learn from that. So here we go. Okay, so this is 2-30. It's the beginning of lesson 2.1.3. And we have a lot of questions to answer about the form of this equation, which is also called the vertex form of a quadratic. Now, what we're going to do is we're going to move some things so we can figure out how the parameters are affecting it. And when I say parameters, I'm talking about a equals 1, h equals 0, and k equals 0. This has to do with our vertical and compression factor, whether we're stretching or compressing. If we had an a on y equals x squared, it would be 1 at this point, because obviously it's a equals 1 there, which I already have set here. Okay, and you have the equation. Let me go ahead and mute this, make sure it's showing up. You have the equation for the parent function right here. And then when I do unmute this, you see that this is the a x minus h squared plus k. And you see that all of these, so right now this is at 1, because if it was at 0, we wouldn't even have an equation. In fact, if I go to 0, watch what happens to the graph. Let's see here. Notice how it lays, if I can get it, notice how it lays flat. That's the red. Okay, the parent function's still okay. But if I make a 0, we have a horizontal line. So let's go back to putting it at 1. This moves kind of fast sometimes. Okay, there we go. All right, so now we're going to play with these a little bit so we can talk about how they affect, how each of these sliders affect it. So first of all, it asks the question, identify the parameters and the effects that each has. Well, we've talked about this does a vertical stretch, the a equals 1, or a horizontal stretch, but once it gets into the negatives, it also flips. So I want you to see that first. So let's go and just do above 1 right now. Let's just go up towards 10. Look at how the red is getting skinnier. This is a vertical compression, a vertical stretch, I should say. Okay, because everything is greater than 1. All right. Then, hang on, let me get back to 1. Okay. Now, as I start going towards the fractions before it hits 0, you'll see compression. Now watch what happens. 0.9, 5, 6. I keep hitting it. But notice how it's like it's flattening it from infinity, okay, till I hit 0. All right, so that's a vertical compression. And that's when A is in between 0 and 1. All right, now let's go to what happens when it starts hitting the negative. Because right now we have a 0, and that means it's a horizontal line. Well, look what happens. Everything goes down below. So when it's in the negative fraction, it's compressing. But then it compresses vertically, or vertically in the negative direction, which is also, when we're talking about A, if the absolute value of A is greater than 1, then it will be a vertical stretch. And if the absolute value of A is in between 1 and 0, here we go. There we go. It's back to the vertical compression. We quickly go up. It flips. It's a vertical compression. Then it will hit the actual function, and then it's a vertical stretch. So that's what happens with A. So let's put that back at 1. Actually, what was I doing? I'm going to go back to 1. All right, there we go. All right, now our H is our horizontal. And I want you to pay attention to this right now. I'm going to go in the positive direction, but I want you to notice what happens to the vertex as I head in the positive direction. So as I go in the positive direction, it's going, if my H, see how it's positive? Okay, Now the problem is, if you look in this equation, when I plug in a positive, it looks like it's going to be, if I'm at x, let's put it this way. Let's go to 3. But I would just be plugging a 3 into this equation. So it would be x minus 3. So you have to think the opposite of what's actually in the equation if it's a horizontal shift. All right, so I'm going to put that back to 0 so there's no horizontal shift. If I can get it back to 0. You just have to have a really patient hand. Okay, the k here is vertical. Now I want you to notice here. See how it says plus k? Well, k is k. So if I have a positive one, it's going to stay plus. If I have a minus, it's going to change to minus k. So let's just start. If I'm going to go up, see how it's shifting up. Okay, I'm going to go back to 0, just temporarily if I can get there. Now we're going to shift down. Okay, so what happens if I'm, let's say, at -1, okay, and I want to do a horizontal shift, but I want to go to the left, so I'm going to go to the left, and I want it to go to 2, okay, and then I want it to go upside down, so I'm going to hit negative. I want to go to -1 though. There we go. So that's a horizontal shift of 2 to the left, 1 down, and it's a -a, so it flips it, okay? Let's change this back to a +1. There we go, okay? So that kind of shows you how all of that works. Now, if I was to do this in a table, I want you to see this in a table. So I'm going to go ahead and convert this to a table. Okay, convert, all right. And this is what happens when it's at 1, and then we're going to change it to 0 here. So we wanted to get it to where it's a parent function. Okay. Take a look at the table. And let's actually just put this also in its table so you can see the changes next to each other. Okay. Right now they're the same. Now, let's go, and I'm going to change this to a 2. Now let's go back and compare the tables. Oops. Notice the change in the table. Everything is doubled. Okay, notice that? It's all doubled. Okay, let's go down and change it to a 3. Look at the table. This is the parent function. Everything is 3 times the value of what it was in the previous table. Now, let's see if I can get it to a 0.5. All right, we're starting a compression. Okay, that's half. Take a look at what happens on the graph. So that gives you an idea of how A messes with the overall vertical stretch or compression based on whether it's a fraction between 0 and 1 or if it's greater than 1, okay? Or the absolute value of greater than 1, because it could flip upside down too. So hopefully that helps. It explains a lot of different questions. And if you also know, the vertex connects to specific points. So it says that, are there points on your graph that connect to specific parameters in the equation? Yes. If you look at this, these are our vertices. So whatever is in H and whatever is in K are your vertex. So if this is a minus H, you've got a positive translation to the right. If it's a plus, that means you're thinking to the left. So these points do have something to do with the points for the parameters. All right. And I think I have covered everything. Let me look at that. Yes, I have. All right. So we are good for 2-30, and hopefully this helps. And it's specifically really going to be helpful to those of you who may have missed class or just need to look at it again after class is over. But this is a great tool, and I will put this link below in the video on YouTube so that it can be played with later and you can actually experience that if you don't have access to it. So thank you so much. So this is 2-31, and it says for each equation below, predict the coordinates of the vertex, the orientation, whether it's up or down, and whether the graph will be a vertical stretch or a compression of y equals x squared. So that's the parent function. It says don't use a calculator, so we won't. We will use a calculator on the next slide to verify our answers to make sure that they're correct. Make an accurate graph based on your prediction. How can you make the shape of your graph accurate without using a table? Be prepared to share your strategies with the class. But we're not in a class, so you can share them with me if you really want to share. So anyway, part A. I'm going to do a little bit of abbreviation on some of these. So when I say A, part A, I say that A is 1 on this one. So 1 would be right in here. So A is 1. It's pointing up. So it's going to open up. The vertex for this one, this is a horizontal shift to the left. So it's going to be -9, and there's no vertical shift. So -9, 0. It has no vertical stretch or compression because the A actually equals 1. It's not greater than 1 and it's not less than 1. So that takes care of, so there's no vertical stretch or compression. All right. Then we're going to go to B. B has no, it opens up again. So A opens up because A is 1. It's positive. The vertex, we have no, if it was, this is like saying X minus 0, okay, plus 7, okay? So there is the X vertex, or the X coordinate of the vertex is 0. And because it's plus 7, it's up 7. There is no vertical stretch, I'm just going to put quote marks, or compression because A is 1. It's not greater or less than 1, okay? On part C, we have, it's open up still because A is positive. So we're going to say open up. There is no, look at this. It's no, this is like an X minus 0 squared plus 0. So really there's nothing. This is at the point of origin. So our vertex is 0, 0. Oh, that looks like I'm doing cool. All right. It does have a vertical stretch with a factor of 3. So vertical stretch of 3. All right, and that's A, B, and C. So now we go to D. D still opens up. We haven't had any that have opened down yet. We will, but this one opens up because A is positive. The vertex is at 1 and then 0 because there is no, so this is like plus 0 out here. There is no vertical translation, but it does have a compression, vertical compression factor of 1/3 because A is less than 1, it's going to compress. All right, so that is D. E, this is the only one that opens down because our A is negative, all right? It has a vertex of 7 because it's minus 7. It's going to be 7 to the right and 6 as our Y value, okay? There is no vertical, there's no vertical stretch. Oh, gosh, I'm sorry, never mind. No vertical stretch or compression, okay? So you can see that's kind of abbreviated there. Part F, we have an opens up. I was just going to put arrows, but it seems to be doing this on its own. Our vertex, because it's a plus 3, means it's 3, it's a -3, so it's going to go to the left, and it's going to go down 8. Okay, so -3, 8. And we do have a vertical stretch factor of 2. Sorry for that noise. That is outside and out of my control. And so now what we're going to do is we're going to go to the next slide just to verify all of our predictions and see if we were correct when I graphed them in Desmos. Okay, so this particular slide is just verifying everything that we came up with on, let's see here, let's just get this. So on A, we said our vertex was at -9, 0, which you can see on the graph there. We said it opened up and it didn't have a vertical stretch or compression, okay? On B, we said it had 0, which it's at, you can tell, 7. And so there's our graph, and it opens up and there is no vertical stretch or compression. On C, we said that, I don't know if I call the last one C or not, but hopefully you're following along correctly. This one's y equals 3x squared. It's at the point of origin. That's our vertex because there's no horizontal or vertical shift. But there is a compression factor of 3, which you can tell is different here as compared to one that didn't have one because it's skinnier, okay? And then on D, we do have it opens up, and the vertex is at 1, 0. It's also a vertical compression, as you can see, and that's because it's wider because of this fraction here. And you can see the difference between that and A and B as well. It's a wider parabola. Then we go to E. E is upside down because it is the only one that had a negative A. And then the vertex is at 7, 6. So you can see that from looking at it, it opens down. It does not have a vertical or a horizontal, vertical stretch or horizontal or vertical compression. I'm so sorry for stuttering through that. It does not have a vertical stretch or compression because A is the absolute value is 1. So it does. The only thing that happens with the A is that because it's negative, it points downward, but it's still the same width and shape of what we would have with the parent function. Okay, F has lots of stuff going on. It does open up. Its vertex is at -3, -8. It has a vertical stretch factor of 2. So those are all things that we verified on the last slide, but I wanted you to see graphs of them to make sure you got them correct. And that is all there is to this particular problem, although it seems like there's a lot. Thanks. Moving on. So for this problem, we're going to have most of it done on the Desmos calculator, and that's because even though we're not supposed to use a graphing calculator, I'm going to treat it as though it's like pen and paper and show you how I would graph it. Graph both of these parabolas on a piece of paper. So most of this will be in the video, and let's just jump into that. Okay, so this is 2-32, and we have two functions that we're going to work with, and we need to be able to graph them without using a graphing calculator. Now, yes, this is Desmos, but I'm going to pretend, see, I have the equation typed in here, but I don't have it, I have it muted right now. But what we're going to do is we're going to use this equation to figure out where I plot points and how I go about graphing this without a graphing calculator. So the first thing I'm going to do is I'm going to make a comment here. This equation is in vertex form. All right, let's see if I can type it. Okay, and so that means I can look at this equation and tell what the vertex is. Typically, we would have x minus h, and then we would have it squared, and then it would be plus k. Oops, okay, all right. So what we can tell from looking at this equation up here is that we have a minus h, which means my 7 is a positive. That means I'm doing a horizontal shift to the right. So my vertex is going to be at 7, comma, and then I'm going to look here. This is my plus k. Well, it says minus here, so that means we're going to go down 2. So at minus 2. Okay, and as you can see here, I've plotted my point. This is my vertex. I also know this opens up because this right here is positive. So our vertex is going to open up, but I can plug a point in and figure that out. So I'm going to go to what is, well, first I'm going to put my axis of symmetry because I like to put the axis of symmetry in because it helps me plot secondary points once I plug it in. So my axis of symmetry is always the x value of my vertex. So I always type a line and it's x equals 7. Okay, so you see the axis of symmetry going through here. You see the vertex down here. And so now you just look at that line and you pick points on either side of it. I'm going to go ahead and just pick 7. Well, we're actually at 7, so I'm going to pick 8. So if I'm plugging in 8, and I can do this on paper, but I'm going to just do it right here. If I plug in 8 here, 8 minus 7 is 1. 1 squared is 1. 1 minus 2 is a -1. So that means I'm going to have a -1 for my next point. Okay, now this is where it gets kind of fun. I mean, I like all of this, so you guys are probably thinking I'm kind of geeky, but that's okay. All right, I am 1 away from the axis of symmetry. So that means I can go 1 away the opposite direction, and it's going to be 6, comma, -1. All right, so there's 2 points now. I have this point and that point. And notice I didn't use this. We're going to use this later just to prove we're correct. Okay, well, I'm going to do one more point. I always make kids plot 3 points. I always make them plot the vertex and then 2 other points, because with a quadratic, it can quickly leave the screen too. If you want to plot more, go for it, but that's kind of what I do. All right, so the next thing I'm going to do, this was 7, we picked 8. Now I'm going to pick 9, okay? So I'm going to put 9. But then I'm going to look at my equation, and if I plug in 9, it's going to be 9 minus 7, which is 2. 2 squared is 4. 4 minus 2 is 2. So that means my point. And you can always stop this video, rewind it, plug it in yourself, work it on paper, totally fine. But this is just being able to use Desmos to help graph it. Because plus, if you saw me doing this by hand, you'd be thinking that maybe it wasn't a quadratic, that maybe it was supposed to be something else. Yeah, it's called too much coffee. But anyway, all right. So I am 2 away from my axis of symmetry with this green point. So I'm going to go to the other direction. Well, that's at 5, 2. So I'm going to plot another point. Now I could put all this in tables, but I don't want to do that yet because I want to just be able to plot the points, because I would do this. This is how I would graph it if I didn't have a graphing calculator. I would plot 1 point at a time. I could go one more. So let's try it. Let's go to 10. Just because we can. All right, and so if I plug 10 into this equation, let's go back up here again. 10 minus 7 is 3. 3 squared is 9. 9 minus 2 is 7. So that means my y value is going to be 7. Okay, now I am 3 away from the axis of symmetry, so I'm going to be 3 away here as well. So that means I'm at 4, 10. So I will put one more point in. So we'll go 4. I'm sorry. Yeah, 4. Got to make 4, 7, not 4, 10. 4, 7. There we go. All right. Now, just to finish this off, to prove that we did this correctly, we're going to go all the way back up here, and I'm going to unmute this graph, and we'll see what it looks like. Perfect. Okay, so this is part B of the same problem, and we're basically it's going to take less time to go through this because we just did it the first time. But again, this is in Vertex. I have this particular problem, this equation, but I have it muted right now so you can't see the graph, which is helping fill in for not having pencil and paper. So I'm going to look at this vertex form and I'm going to figure out what I have. Well, this says x plus 3. Well, this is minus h, which means we put a negative 3 into it because it's a minus 3, so it should be plus 3. So our vertex is going to be at negative 3 for the x value. The y value is just whatever this sign is, because you see it's plus k here. So that means we're going to go up 1, so it's positive 1. All right, so I'm going to go ahead and plot that point. There's my point. Now, we talked earlier about my axis of symmetry, which really helps me graph. I'm going to use my x equals negative 3 and draw the axis of symmetry. So x equals negative 3. There we have our axis of symmetry. That helps plot points as we choose them. Okay, so now I just need to figure out points around my negative 3 that I want to use. And I kind of like to avoid fractions. This is not something you have to worry about, but it's kind of fun to avoid fractions when you have a 0.5 outside. So I've chosen negative 1 as a point because I know what's going to happen when I plug it in. If I put a negative 1 in here, it's going to be a positive 2 squared, which is 4. Then it's multiplied by 0.5, so that's 2 plus 1, so it means my y equals 3. All right, so I'm going to put 3 in there. Perfect. So I have negative 1, 3. Now, I'm 2 away from the axis of symmetry, so I'm going to go over 2 to get my next point, which is at negative 5, 3. So let's plot that point. Negative 5, 3. All right, we've got 2 nice points. They look symmetrical. We're going to pick one more. And so another point I picked was a positive 1, because again, I'm trying to avoid fractions. So I'm going to plug in a 1. Okay, and 1 plus 3 is 4. 4 squared is 16. 16 times 0.5 is 8. And 8 plus 1 is 9. So 9. I'm sorry. I hope you're following all that math when I do it. If not, you can always just write it out in paper. Plug in the x value I'm giving you, put it into paper on the equation, and see if it makes sense to you. All right. So I have 1, 9, okay? And I'm 1, 2, 3, 4 away from the axis of symmetry. So I'm going to go 4 more. 1, 2, 3, 4. So that means I'm at negative 7, 9. So that's going to put my last point in. So negative 7, 9. There we go. All right. So this looks pretty good. They look pretty symmetrical. So we're going to go all the way back up here to the top. And we're going to go ahead and unmute this function and see if we are correct. We are correct. That is the best way to graph a parabola, with just the vertex form and then adding points in that are around it. So that ends 2-32. And we're moving on. Okay, so this is 2-33. And it's going to be done in 2 slides because there's so much to cover. But in this first part, A is pretty easy. It's just saying, what is the orientation of this parabola? Does it open up or down? Well, this parabola will open upwards because the A term is positive. If we wanted the parabola to open downwards, we would change the 2 to a negative 2. On B, it's asking you what the stretch factor is. Well, this one has a stretch factor of a vertical stretch of 2. A is greater than 1, so that points to a vertical stretch and not a vertical compression. So that's all there is to that particular part of the problem. Now we're going to move on to the more detailed part. So for this part of the problem, we have 2 ways that we can solve this 2x squared plus 4x minus 30 to get it into the vertex form. You will see it says, can you identify the vertex from looking at that equation? I myself can't. I always have to work through a process to figure it out. But if not, talk with your team about strategies you could use to find the vertex without using a table or graphing calculator, and then apply your new strategy to the problem. Now, it says here on here, if your team is stuck, consider doing parts 1 through 3 below. You can look at those. That's totally fine. But I'm not, I didn't list those because I'm just going to go over it. And then we will ultimately, with part D, show what a graph of this looks like to make sure we are correct. So the first method I'm going to use is called averaging zeros. So you're either averaging your zeros or x's. It depends on how, I'm not sure how to pluralize x's, but anyway. All right, and so the first thing we're going to do is we're going to factor, and I'm going to set this equation equal to 0. We're going to factor 2x squared plus 4x minus 30, okay? And when we're doing that, we're still going to start out with the diamond method, but we have a leading coefficient that is not 1. So it's a little trickier, but that's a process that's easy to do. It's just called factoring by grouping. So that's what I'm going to show you right now. And so I still have A times C, but in this case, it's negative 60 because it's A times C is 2 times negative 30. Then it has to add up to 4. So I have to have 2 numbers that multiply to negative 60 and add up to 4. That is 10 and negative 6. So what I do is I come down here and I'm breaking apart this particular term. So it goes back to, like, if you FOIL or use the box method, you have 2 terms that you end up adding together to get the middle term. So I'm going to write out 2x squared, and then I'm going to say minus 6x. It doesn't matter which one you use first, plus 10x minus 30. But then I always say break the equation in half, and I'm going to factor each half, okay? So I'm going to factor what's common. So I'm going to take out on the first half is a 2x, which leaves an x minus 3, okay? And then on the other side, I'm going to take out a 10, and that also leaves an x minus 3. Ideally, you want these two to be the same. So that's kind of what your goal is when you're factoring by grouping. So now what I do is I take and I write x minus 3 down here. That's one factor. It only shows up once, and I cancel those out. Then I look at what I have left, 2x plus 10. This is a method you're going to want to rewind occasionally and practice. I'm happy to help, so you can always leave notes in the comments of the video, and I can get back to you with an additional video. But anyway, this one will evaluate to x equals 3, because remember, we have to have the sets of parentheses evaluate using the zero product property to, they have to evaluate to 0. So this one will evaluate to x equals negative 5, okay? So we have our 2 zeros. So now what they're asking us to do by averaging the zeros is to take 3 plus negative 5 and divide it by 2, because there are 2 zeros. So our average is going to be -2 over 2, which equals a -1. This is the x of your vertex. And the only thing you have to do now is find the y of the vertex. Well, you can do that by plugging it in to the original equation. So 2 times -1 squared plus 4 times -1 minus 30. Okay? So that equals 2 times 1, so it's 2, minus 4, minus 30. That equals -32. So our vertex, so this is the y of our vertex. And so if we want to put that into the vertex form, we would take our vertex, which is, our vertex is -1, -32. So we're going to say y equals x plus 1 squared minus 32. Okay, and I will show you a graph for this on part D when we get to it. So let's go, there's another method I want to show you called completing the square, and that's going to help us with the last problems because sometimes completing the square is easier and sometimes finding the zeros with averaging is easier. So we'll take a look at that. Here we go. Okay, so this one is completing the square, and so this method. So I'm going to write out the original. Okay, and my goal is to get it into this form here. So I need to come up with a perfect square, and that's x minus h squared is a perfect square. So that's what I'm trying to get to. So the first thing I'm going to do is I'm going to get rid of 30. I'm going to move it over to the other side by adding 30 to both sides. All right, then we have our 2x squared plus 4x, and then we've got to do some factoring. So I'm going to have 2. And inside it's going to be x squared plus 2x plus a blank because we do need to finish off our square. Then I'm going to have a y plus 30 plus a blank. Okay? What goes in the blank? The blank, for lack of a better term, is just b over 2 squared. Okay? Over here, I'm going to have to put, so this one gets b over 2 squared, and in this case, b is 2 because of this number right here. So we have 2 over 2 squared, but it's also multiplied by 2. So over here, we have to put in 2 times 2 over 2 squared. So this becomes y plus 30 plus 2. This becomes 2 times x squared plus 2x plus 1. Okay? All right, let's take this over here. I'm going to go ahead and erase all of this right here. Okay. Now, we take this up here. I'm going to consolidate the left by combining like terms, so y plus 32. And then on the right, I've got my 2, and this factors to x plus 1 squared. So it's x plus 1 squared. Do you see where we're going here? Okay, we now have our -1 for our vertex here, and all I have to do is move 32 over to finish it. So it becomes y equals 2 times x plus 1 squared minus 32. There's your vertex form using completing the squares. The square. Now, this ultimately can be the easiest way to do it. And when we get to 2-34, I will do a couple of them with averaging the zeros, and I'll do a couple of them with completing the square. And then it's up to you to figure out which one you like best. But I'm willing to help you on both. Okay, that ends oh wait, no, that doesn't end it. Hang on just a moment. I have to get the picture of the graph for you so you can see that we are correct. Just a moment. And so now you can go ahead and you can see that we have this in vertex form and that our vertex is -1, -32. So we did it correctly. And that ends 2-33, which I know took a long time, but this is kind of a deep concept, and both of these methods can be used going forward. So it's really important for you to be able to do as many methods as possible. And we're moving on. Okay, so this particular problem is the last one for the lesson. It says rewrite each equation in graphing form and then sketch a graph. Label each sketch so that it's possible to connect it to the equation. We will show you the graph after, I will show you the graph after I'm done going through the problems. So the first thing we're going to do is rewrite each equation, and I'm going to use both methods. So on part A, I'm going to use completing the square. So I'll just say completing square. All right, let's start it out. I'm changing it from p of x to y equals x squared minus 10x plus 16. And on completing the square, we need to move the 16 over, move the constant over by subtracting it. Okay, then we need to add our little blank here, which we said earlier was b over 2 squared. And so x squared minus 10x plus our square. Now, the thing that's different on this one is we had a vertical stretch factor on the last one. This one, luckily, is easier because you don't have any a other than 1. So you don't have to worry about multiplying whatever you add in to the other side. So in this case, our b is -10 over 2 squared. So -10 divided by 2 is -5, squared is 25. So we are adding 25 to both sides. Okay, the next step is just combining like terms. So we're going to have y plus 9. And then we're going to have x squared minus 10x plus 25. All right, we are going to factor the right side. So if you use your diamond method, what two numbers multiply to a 25 and add up to -10? It's x minus 5 times x minus 5. So we've got x minus 5 squared. Then the last thing we need to do to get this in vertex form is subtract 9. So our vertex, according to this, is at 5, -9. We'll check our drawings. We'll check the graph in a few minutes and show that to you. Okay. All right. Part B, let me do it in a different color. Part B, I'm going to go ahead and average the x's, okay? So we've got, this is averaging x's, or zeros. I'll say zeros, because it's our solution. So I'm going to go ahead, I'll leave it as f of x, that's okay. And I'm going to, let's just write it out. Diamond method, two numbers that multiply to a -10 and add up to 3, +5 and a -2. So we'll say x plus 5 times x minus 2. Then we're going to average our zeros because it's x equals -5 and x equals -2. All right, so, or +2. So -5 plus 2 over 2 is a -3/2. So -3/2 is our x of the vertex. Okay, that's our x. So we have to plug it into our equation. So if I plug it into my equation, I've got -3 to find out what y equals. -3/2 squared plus 3 times -3/2 minus 10. Okay, that is 9 over 4. This would be a -9 over 2, but we need to have it have the common denominator, so we're going to double that. So it'll be minus 18 over 4. And then our -10, I can't add that to it until we have a common denominator as well. So I'm multiplying that by 4 over 4. So it's going to be -40 over 4. Then I just combine all of the numerators on top. And that's going to be 9 minus 18, which is a -9, minus 40 is a -49 over 4, which is a -12.25. So our vertex, if you could follow along with all of that, that's the y of our vertex, is, let me write that over here. Is y equals x plus 3/2 squared minus 12.25. That's the vertex form of our equation. Okay, vertex form of our equation over here. Let me write that, vertex form would be y equals x minus 5 squared minus 9. Okay, so those are done in graphing form. That's what you used to have. This is tricky, the vertex form for the second one, but you will see it's correct when we graph it. So let's move on to the next two. We'll do C and D, C and D, and then we will show you the graphs of them. So just a moment. Okay, so part C, I'm going to go ahead and we're going to do completing the square. So I'm going to change the g of x to y equals x squared minus 4x minus 2. And the reason I chose completing the square on this one is it's not factorable. You would have to do the quadratic formula to factor this one, so it's much easier to complete the square on this. In fact, I recommend, if it's not factorable, just to go ahead and complete the square because it'll be, you'll see, it's just a lot easier. So I'm going to add 2 to both sides. I'm going to add the blank while I'm at it. And then I'm going to add x squared minus 4. I'm going to have x squared minus 4x plus the blank. Okay. In this case, my b over 2 squared is negative 4 over 2 squared. So that is negative 2 squared, which is 4. So I'm adding 4 to both. Again, I don't have a vertical compression or a vertical stretch, so I don't have to worry about an a being different. So and then the next step on this would be y plus 6. Okay. And then we would have, if I factor this, what 2 numbers multiply to 4 and add up to negative 4, just negative 2 and negative 2. So x minus 2 squared. Then the last thing I'm going to do is move it over. Move over the 6th, and that's your vertex form, but it means our vertex is at 2 and negative 6. So much easier on completing the square on that one, especially since you can't factor that one to begin with and find the zeros, because you would have to look. There's not 2 numbers that multiply to a negative 2 and add up to a negative 4. So, okay, let's move to part D. D, I'm going to use averaging the zeros. Okay, so we have our, I'm going to set it equal to 0 because we have to factor. It's going to be negative 4x squared plus 4x plus 8. Okay, and so what I'm going to go ahead and do is figure out, I've got to do my diamond method. So my A, C, and my B. So A times C in this case is negative 32, and the B is a positive 4. So our 2 numbers that multiply to a negative 32 and add up to 4 are 8 and negative 4. Oops, I don't know how that got changed to black. Hang on just a moment. Are 8 and negative 4. So I'm going to come down here and I'm going to go ahead and break apart this term. So it's going to be negative 4x squared minus 4x. And then I'm going to say plus 8x plus 8. And this is where I actually break apart the equation. That's what I always say, but it's not true. It's actually factoring by grouping because I want to factor 1/2 at a time. So I'm going to take out a negative 4x, which leaves me with an x plus 1. And then I'm going to take out an 8, which also leaves me with an x plus 1, and that's what I'm looking for. So I come down here, and one of my factors is x plus 1, so I can cross those out. What is left is a negative 4x plus 8, okay? So x equals negative 1, okay? And then when you set this other set of parentheses equal to 0, you get x equals 2. Okay, so then what you have to do is you have to average those together. So we're averaging. So that means it's 2 plus a negative 1 over 2, which equals 1/2. Okay, so 1/2 is our x value. So now we're going to solve, and I'm going to come over here and do this because we're running out of room. I'm going to plug it into the equation. It's going to be, I think I can fit it down here. So I'm going to say y equals negative 4 times 1/2 squared plus 4 times 1/2 plus 8. Okay, well, 1/2 squared is 1/4. 1/4 times a negative 4 equals a negative 1. Then 4 times 1/2 is a positive 2. And then we have plus 8. Okay, so that means y equals 7. So that's the y of our vertex. And this is our x of the vertex. So our vertex form of the equation, see, sometimes this just takes longer than completing the square. But our vertex form in this case would be y equals x minus 1/2 squared plus 7. So now what we're going to do is we're going to go back, and I think I might have added those wrong. That's right. This is 9. 9. Sorry. It's the easy stuff that I screw up. So I fixed that. So we're going to go back, and I'm going to show you the graphs of these so that we can prove that we are correct. And let's show you the graphs. Okay, so for part A on this one, we actually graphed this out. This is the actual equation, and we came up with 5, negative 9 as our vertex. Now let's see if our equation that we came up with vertex form is correct. So we're going to type that in. F of x equals x minus 5 squared, and then we're going to do minus 9. And what should happen when I hit minus 9, the green should no longer be visible, and you should see the purple. So minus 9. And we did that correct. So that is part A. Let's look at part B. So this is part B. And part B, f of x equals x squared plus 3x minus 10. We solved for a vertex of negative 3/2 and a negative 12.25, which if I come down here and I hit this point, we definitely have that vertex. Let's see if our vertex form of our equation was correct. We have y equals, and then it's x plus 3/2. And then that is squared, of course. And then we have minus 12.25. All right. And you notice we went from black to red, which means we have the identical equation, and we did it correctly, even though it's in decimals and fractions that we don't usually use. So, and I could have just left it too as minus 49 divided by 4. That would have been the same thing. So, all right, moving on to part C. Okay, so this is part C, and we did complete the square for this one, and we found out that our vertex should be at 2, negative 6. As you can see here, we are at 2, negative 6. Now let's check out our vertex form of the equation. It was y equals x minus 2 squared, and then minus 6. So again, when I hit minus 6, that green should now be over the top of blue, and you shouldn't see blue at all. Oops, I didn't do minus 6, I did minus 2. Minus 6. There you go, it's correct. All right, let's move on to part D. Okay, so this is part D, our final one for the review, or for this lesson, not review, preview. I'm getting ahead of myself. We had negative 4x squared plus 4x plus 8. We did come up with a vertex of 1/2 and 9, but we also have to remember we have a vertical stretch. So when we did our vertex equation, we had to be careful of what we wrote. So it is 0.5 and 9, which you were correct there, but we have to make sure that we don't forget our negative 4, okay, on the outside, and then it's x minus 1/2 squared, and then minus or plus 9. There you go. Before I did the 9, they weren't in the same place, but once I hit the 9, you can tell they're the same equation. You just have to be really careful. Don't forget those factors, those vertical stretches and compressions. All right, and that ends 2-3-4, and we're moving on, and we'll see you in review and preview. Don't forget, if you have questions on any of the problems in this particular video, please leave them in the comment section of the video. I'd be happy to get back to you and help you. Also, please hit that thumbs up if you like the video, and subscribe so you can get the rest of the videos. Again, I'm in the middle of Algebra 2, and I will eventually put Geometry, Algebra 1, and Pre-Calculus also online. So hopefully you have these resources to help you with the future math. Thanks.